All right, so this is chapter 4, section 6. The title is Completing the Square. Our learning objectives are to solve equations by completing the square and to rewrite functions by completing the square. So our action item here is completing the square. After the end of this section, if you do not know how to complete the square, please let me know. So the first thing I'm going to do is I'm going to show you guys how to solve a equation when you just have an x squared. So I don't have an x, I just have x squared and numbers. So the first thing that you guys want to do is you want to get x squared on one side, everything else on the other. And for 7x squared minus 10 equals 25, I'm going to add 10 to both sides. 7x squared equals 35, sorry. Then I'm going to divide by 7 to get the x squared by himself. The next thing I'm going to do is to get rid of a square, we take the square root. The only thing we have to watch out for is when I take the square root of both sides, it undoes the square, but the magical property of square says when I take the square of something, it doesn't matter whether it's positive or negative. So when I am trying to solve for a squared function, I'm going to get out the positive answer and the negative answer because those are both possibilities of solutions for when I plug in the answer to my final solution. So when you're taking the square root of both sides, make sure you put a plus and a minus to solve. Keep it in exact form, so that we're going to keep this as square root of 5 unless they ask us to approximate and then tell us where to round. Otherwise, we're going to keep this as plus and minus square root of 5. Okay, so we're going to follow that same process here. With b, we're going to subtract 9 from both sides. 2x squared equals 13 minus 9 is 4. Divide both sides by 2. X squared equals 2. So when I take the square root of both sides to get rid of my squared, x is equal to the square root of 2, and x is equal to the negative square root of 2.
Oh, I see you write it like that.
Both of these ways are correct. All right, so we're going to solve this problem together. The lengths of the sides of a rectangular window, so let's have a rectangle here, have a ratio of 1.6 to 1. I'm going to make this the 1 and this the 1.6. Although that is a ratio, so I have to put 1x and 1.6x, because I don't know if it's 1 meter to 1.6 meters or 2 meters to 3.2 meters. I'm not sure. I just know the ratio. I don't know the actual dimensions. So I have to have an x there. And I know that the area is 2822.4. Oh, these are square inches. Square inches. Area is length times width. So if I need a little equation, like a little quadratic equation, I'm going to say my area is equal to x times 1.6x. And we know that is 2822.4 is the actual area, equals 1.6x squared. So the next step is to divide by 1.6 because we want the x squared by itself. And I'm going to get this wonderful invention called a calculator. I technically could do this by hand.
514.
514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 514. 5
Good job, Nick.
1,764?
Good.
1,764?
Well, it only didn't get the extra 2 at the end. It only got 822.
And then we're going to take the square root of both sides. And we get x is equal to plus or minus the square root of 1,764, which is 42. Now, this is a real problem, so we can't just go, yeah, negative 42 and positive 42. Let's look at what it's asking us. What are the window dimensions? Would it make sense for my window dimension to be negative 42 inches?
No.
Not at all. So I can definitely with certainty say that 42 is my x dimension for the window, which would leave our other length to be 42 times 1.6, which is 67.2. So our answer is 42 inches and 67.2 inches. All right, so now we're going to look at a scenario where we have a perfect square trinomial. So we did this yesterday. Remember, it was that we had a square that's on the front and the back, and then we had double the product for our center term. So if we look at this guy right here, x squared minus 14x plus 49. So the square root of x squared is x, the square root of 49 is 7, but I'm going to have to make it negative so that we can get a negative 14 for our middle. That is squared and he equals 25. How is this any simpler than what we had before, you ask yourselves? Well, what we're going to do is we're going to square root both sides to get rid of the square. So we get x minus 7 equals plus and minus 5. Easy, right? So this actually gives us two equations. We get x minus 7 equals 5 and x minus 7 equals negative 5. The solutions to both of these are solutions to this problem. So we're going to add 7. We get x equals 12, and then we add 7. We also get x equals 2. Both of these are solutions for x. What is the solution of x equals 12 and x equals 2? And then if we go ahead and plug those in to here, we should get out true statements both times. I'm going to give you guys a second to check your answers. All right, so both of these work when we plug in 25 for the x, or sorry, when we plug in 12 for the x, we get 25 on the left-hand side. And when we plug in 2 for the x, we get 25 on the left-hand side. So both of these are solutions to this problem. All right, now we're going to become math ninjas. And we are going to set up our equations so that we have a perfect square trinomial. So then we can take the square root of both sides and get the solution to our problem. Or take a polynomial, take a quadratic and standard form, and put it into vertex form so we can graph it and look at it a little bit easier. So when we complete the square, we start out with x squared plus bx. If you don't have a 1 in front of your x squared, you divide everything by whatever's in front of your x squared, so you get a 1 in front of your x squared. This only works when you have an x squared with a coefficient of 1. So to complete the square, we take whatever value is in front of our x, this b value. We divide it by 2, then we square it. When we do that, we can then have our x plus b over 2 parentheses squared. So let me show you how that works. I have x squared plus 6x. D in this situation is 6. So I'm going to take 6 and divide it by 2 to get 3. And then I'm going to square it to get 9. So the value that completes the square is 9. When I add 9 to both sides, I now have x, the square root of x squared is x, square root of 9 is 3. It gives me a value that is x plus 3 squared. So the mathematical operation of finding the value that completes the square is to take the b term, divide it by 2, and square it. Okay, so if I want to solve an equation by completing the square, and you guys can abbreviate this so that it's in your terms and not the mathematicians who wrote this book's terms. We want to rewrite the equation so that we have x squared plus bx on one side and c on the other. So we want to get all of our numbers that have no x's attached to them onto the right-hand side. We want to keep everything else on the left. If we have a coefficient that's not 1 in front of the x squared, we're going to take that opportunity to divide everything by that coefficient. Then I'm going to take whatever my b value is, divide it by 2, and add it to each side. Then we'll factor, then we'll take the square root of both sides, and then we'll solve. Okay, so if we have an equation like this, 2x squared minus x plus 3 equals x plus 9, I want all my numbers on the right-hand side, everything else on the left. So I'm going to subtract 3 from both sides. And I'm going to also subtract x from both sides. Now I have all my x's on the left and all my single constants on the right. I don't have a coefficient of 1 in front of my x squared, so I'm going to divide everything by 2. When you divide everything, when you do division all the way across your equality, every term in your equality gets divided. So 2x squared divided by 2 is x squared. Negative 2x divided by 2 is negative x. 6 divided by 2 is 3. So now we have everything set up so we can complete the square. All right, now we have to identify what our b value is. So it's x squared plus bx. So in this case, our b is equal to negative 1.
You can't simplify it anymore, right?
So because our b is negative 1, we're going to add b over 2 squared to both sides. So let's actually plug in the b. Negative 1 over 2 squared is negative 1 times negative 1 is 1, and 2 times 2 is 4. So we're going to add 1/4 to both sides. We are in a equality situation. So if I do it on one side, I have to do it on the other side as well. I can't add 1/4 just to my left-hand side and not also add it to the right-hand side. I'm required by the laws of mathematics to give them both equally 1/4 to each side. Keep it balanced. So once I have my 1/4, I can then factor. This becomes a perfect square trinomial. The reason we do completing the square is so we can get a perfect square trinomial and factor it minus 1/2. So you want to look, when you factor it, the number that goes into our factored form is the number that we get before we square. So it's our b divided by 2. Three and a fourth. 3 1/4, that's 3 times 4 is 12, plus 1 is 13, so it's like 13 over 4. 3 times 4 is 12, plus 1 is 13. I just made 3/4, 3 1/4. And that's 13 over 4. Just find them, simplify fractions. So I'm going to take the square root of both sides. So this is what we were doing before. So I get x minus 1/2 equals plus and minus the square root of 13/4. To solve for x, I gotta add 1/2 to both sides. So I got x is equal to square root of 13 over 4 is equal to the square root of 13 over the square root of 4. We know what the square root of 4 is. It's 2. So I can say that my two answers are, and I have a common denominator, so I can combine these two together. So my first answer is 1 plus square root of 13 over 2, and 1 minus the square root of 13 over 2. Okay, so we're going to take a quadratic equation and we're going to use completing the square to put it in vertex form. If you guys don't remember, vertex form is y equals a x minus h squared plus k, where the vertex is h comma k. It's beautiful for graphing when we have the vertex because we know where the axis of symmetry is. We know just a lot of detail about it. So we're going to use completing the square to transform our standard equation into a vertex form equation. So I'm going to ignore the minus 6. He's just going to stay. I'm going to look at my x squared plus 3x and identify the b. What's the b? It's 3. So if and then I'm going to add 3. So we have to make sure we're doing things, we want to keep things equitable. If we don't keep things equitable, then we're not an actual equation. So I'm going to go x squared plus 3x plus, I'm going to fill in this little box. But guess what? If I add whatever value I'm going to add to this equation, I better doggone subtract that same value. If I add it to one side and subtract it from one side, it does it. I'm adding 0. So this is where we're being math ninjas. So I'm going to add my b over 2 squared. So that I can get a perfect square trinomial. So this is equal to 9/4. So if I'm adding 9/4, I better also subtract 9/4. So once I add my 9/4, I can then convert this perfect square into its factored form. So we got x, we take what's inside before we square it, plus 3/2. And then I simplify -6 minus 9/4. -6 minus 2 1/4. -8 1/4. So now we can say my vertex is at h comma k. So it's at, let's convert it to decimal so that we can, if we actually have to graph, we can graph it a little better. 1.5 comma -8.25. So we put it into vertex form. The vertex we name, and the y-intercept is -6. We find the y-intercept by plugging in 0 for x up here. So if this is 0 and this is 0, then my y-intercept is -6.